please welcome to the stage Intrinsic's Wendy Tan White, Brian Gerkey, and our moderator today is Haya Jan Kamps. Please welcome them to the stage.
Hello, everybody. Thank you for joining us. So, the world of everything is getting more and more automated, right? No code and low code is everywhere. And yet, if you try to program a robot, things get very tricky very quickly. I'm joined by two of the smartest people I know in robotics to talk about what is happening there. Wendy, could you tell me a little bit about what you're working on?
Yeah, so the aim of Intrinsic is actually democratize the access to robotics. So as you said, at the moment, we do a lot of digitization to actually make tasks happen. How do you actually make that happen in the physical world, in the way we're actually starting to see that in digital world, particularly with the advent of AI shifting? When AI really becomes embodied fully, how is it actually going to touch our physical space? And with Intrinsic, we're actually want to let a normal developer or a process engineer actually build a robotics AI application very quickly, and one that can really make a difference for you in your real-world task you're actually trying to do.
Yeah. And what is the contact surface there between what you're trying to do and what's happening out in the world?
We've actually enabled a system such that you can have a software platform to build an application in simulation. They can actually be deployed. The same application that you see running in simulation will actually run physically onto a deployed work cell as well. So you can actually do it. You could literally use a web browser to design that and actually be running a work cell across the other side of the world if you actually chose to. So we're really opening up the access and who can actually use this and design it. And the applications people are using could be anything from manufacturing, assembly, logistics. We're seeing companies, in our recent beta program that we started, we're seeing companies doing things in lab automation, process engineering. We're seeing them doing it in agriculture, small businesses, and large. So it's been quite a powerful tooling.
And what are the kind of robots? Am I imagining the type of robots that you're actually programming this way?
We're both looking at industrial grade robotics, so really quite large physical robots, for example, like Camaro robots, right through to smaller cobots like Universal type robots. So we're actually trying to make it agnostic, both the size and the type of robot we're actually able to use.
Mm-hmm. So software to hardware agnosticism is whenever I talk to people about that, you get this, that's almost impossible. Brian, are you trying to do the impossible?
Maybe, but
cool, great interview. Let's go.
I think we've got a really great track record to build on. So the team that I was leading before we joined Intrinsic, is Open Robotics, where we developed what's called ROS, the Robot Operating System. So it's perhaps the best example in the world of a software platform that is in fact hardware agnostic, in the sense that you can take, different robots can look different, but if you break them down into pieces, they have common kind of equivalence classes of functionality. So you've got cameras, you've got lasers, you've got motors, you've got encoders, you've got force torque sensors. You can kind of put those things into buckets and then have interfaces to them. And then as long as you define those interfaces well, you can start to write applications on top. I mean, this is what has enabled the personal computing industry. It's what's enabled mobile devices. These things, if you look at the details, they can be different, but you can have this abstraction that allows you to write these applications that can run on even different physical embodiments. So you could write an algorithm that makes a robot move around the world, and it could run on a wheeled robot, or it could run on a legged robot, as long as you've got the right details implemented underneath. So I think we've actually figured out as a field how to define those abstractions pretty well over the last 20 years. And what we're doing at Intrinsic is really taking that to the next level, and like Wendy was saying, making it really accessible to everyone, taking those ideas and presenting them to you in a way that just through a web browser, you can access those underlying abstractions and write these applications that can run on many different robots.
And so am I imagining this as different robots working together on a common task, or are you using these tools to program each individual robots and they just kind of have to fight it out among themselves?
So I laugh because I did a whole dissertation 20 plus years ago on multi-robot coordination. And I'd say as a field, we're really still not there in the sense of having robots that are intensely, like really cooperating with each other as opposed to just working kind of near each other. There are still some deep research topics there that in fact some folks on our team are also looking into. I'd say in the near term, there's so much value to be had from just having a robot do a task and do it really well that we tend to focus there. I still hope that we'll get to the point where we'll have, teams of robots really working effectively together. That's going to take a little bit of time.
And what is the programming piece of that? Like, it's been a hot minute since I programmed the robot. It was very, very hard back when I was doing any sort of automation stuff. Like, what is the pieces that you are adding to this mix to make that easier?
I think maybe the analogy is much like my first company was actually it was a SaaS-based website builder, probably the first in the world. Now, pre that, if you wanted to build a website, you'd have to build your own server, your own middleware, add your own front end, add your own commerce, add your own. We're actually creating a place now for Intrinsic, which is in a one-stop shop. You can actually have all of that underlying stack there, and you can basically use effectively a graphical user interface to build the workflow you want for that application. Or if you want to actually go in and do a bit more of a code level, we also provide a better user interface for actually even coding and scripting at that level. And we also make it easy for you to use things like AI skills and components, as well as different types of hardware. So if you want to add something in, for example, like computer vision, also in a more sophisticated way, or force feedback skills, where you can feel your way into a task, that's also going to become available to you. And we're opening it up so other skills developers can actually add those skills in too, and different types of hardware. So we really want to actually help the ecosystem as much as the end user be part of this.
And to what degree are you able to do that across all robots? I mean, I keep being hung up on this hardware agnosticism thing because, that feels incredibly hard.
I think much like other devices, it still requires some sort of integration driver to add to a platform to do that. But I think we've abstracted it enough. It becomes more of a production engineering job now to add that in quickly, rather than have to customize something in a very sophisticated way. And where we can, we will use common interface to do that. For example, with Brian coming on from Open Robotics, Ross has some of those sort of APIs that exist already that abstract quite a lot of different types of hardware. And of course, now we're together, we've actually taken advantage of that too. And we'll continue to improve it.
Yeah, I'll say that I think probably the view you have of the, writing automation software for like industrial robots, collaborative robots, kind of I would say the older way of doing that is to develop it all really in these company, like kind of proprietary specific tools, and even sometimes specific languages that were developed by the manufacturers of those robots. And then the problem is then you can't really port that to another robot. But in point of fact, if you stand back and you look at the robots, they might be different colors, they might be made by different manufacturers, the links are different lengths and so on, but really at the level that you need to reason about that robot in order to control it to do something useful, they're not that different. And so we can write these abstractions that sit on top and let you port applications across them.
And so to what degree are you able to take one robot out and swap it in with a different one and just say, well, yes, it's slightly different, but it can lift the same amount, it still fits the purpose, let's go?
We've actually done that with some of our initial application examples that we've already built. So we can, we can take in, like Wendy was mentioning, we support the, universal robots, the collaborative robots. We can swap that robot out for, say, a robot from a manufacturer like KUKA, and they're physically different, but we can get the same work done between the two robots. And this is actually potentially a game changer for people who want to use robots, because you really want to have free choice, right? It could be that next year, for whatever reason, you want to go with a different vendor for a new robot line, and you'd like to be able to reuse the work that you put in to develop the first one. And that's actually quite difficult right now.
Yeah, no, that makes a lot of sense. On our prep call, you mentioned something along the lines that software really is the frontier of robotics right now. Does that mean that hardware is pretty much solved? Like, do we have all the hardware robotics we need?
No. I mean, the physical world is still, there's still mechanics involved, there's physics involved,
Yeah.
there's real world forces involved, and those things still need to be solved. So I think one of the things we're actually working pretty hard on in partnership with other people, with folk like DeepMind, for example, is in the area of simulation as well. And actually, how do you get more of a real world modeling and simulation than, because it has to be accurate. It has to be accurate.
Right.
If you had a robot eventually in your home, if it's a couple of degrees off, it's going to hurt you. Yeah. And that isn't what we need. So we're still having to move forward in that. I think with the advent of compute, the step changes in compute right now,
Yeah.
and actually, to be honest, AI and modeling there too, I think that's going to improve very quickly now. So we're also working with folk in that arena.
Well, and this is the interesting thing, right? So physics are pesky,
Yep.
humans are soft and squishy, and robots usually aren't.
Yep.
And like in industrial, like in building cars, you see all those big robots all the time. But the sense I'm getting is that part of what you're trying to accomplish is bringing robots into smaller processes and products, and like where it's either built by hand or like semi-automated, but actually getting more automation there. Is that part of the goal that you're trying to accomplish?
I think very much so, because we're looking to democratize the access. And democratization means it's not just to preserve big, let's say automotive factories, but actually how do we bring it to the small businesses, to the small warehouses, to the makers, to the retail, to commerce, etc. And to do that, you do need different scales, but different accessibility. You want to be able to almost bring what would happen if you brought a small cell into your home? How would that work? And actually, we're pleased that 60% of our beta users are small businesses, not just the big companies. We also do have the automotive and the electronics, etc., aviation, but we also have 60% that are actually smaller businesses. And actually, in that, we think we'll change the industry, and that there'll be more players who can actually build the applications for those businesses, the smaller end-user businesses.
But I'll say that we can't do it by ourselves. So, I mean, you just had Gil Pratt from Toyota Research Institute and Mark Rabert from Boston Dynamics AI Institute up here. And the work that they're doing, I think you saw some of the examples of kind of next generation dynamic systems from Mark, and also Gil's team is working really hard on how to do some of the tasks that, like Wendy was just alluding to, where you imagine having a robot in your home doing something for you to help you live there longer and being able to do those kinds of things safely. There's a whole bunch of work that needs to happen there, actually back in the hardware. So we need the hardware to be intrinsically safe. We need to understand how the control algorithms are implemented. We need to understand what kind of motion planning is required. So that, like, the way that I think about it is we've got a whole community, fortunately, who's working on some of those underlying pieces. And as they become available, we'll be collaborating with them, and we'll be able to expose them to a really broad audience through what we're building at Intrinsic.
Yeah. You said you had 50, 60 beta users out there. Can you say something about like what are they actually doing with the software to help, well, do their thing?
Yeah, so the initial, what we've had them be doing over the last 6 weeks is we've provided them with a kind of a structured curriculum where they're going through tasks that we think are, that we know that they're kind of very common in the industrial world. And so you think about moving objects around, so kind of pick and place type tasks, as well as we see a lot of use for what you can think of as like machine tending, where you're taking an object and presenting it to a machine to have some process done to it. And so we've sort of canonicalized those sorts of applications, and our beta users are really going through the steps of building applications that look kind of like those things. And we're getting feedback from them to be able to improve the software so that they can go from there all the way to a deployment of an application like that. And we feel like there's a lot of work that can be done with the robots that are available today that look kind of like those applications that people aren't able to do yet today,
Right.
Not in an economically viable way, because it's just too difficult to program it, and so people don't put the effort in to program it, and instead they'll do it by hand, or they just won't do the work at all.
Yeah.
I mean, maybe something to say as well is that the 50 to 60 that are in the program at the moment are a group we've picked out of, we had over 1,000 companies apply. and 50 and 60 are in what we call our private beta right now. Actually, from October, we're going to open it up more fully. So we'll invite more of that 1,000 in, but also, to be quite honest, at that point, we'd also love to invite other people in if they want to actually try. So if you have a burning application you want to try out, even if you want to build it in simulation first, just to play, we're here. We also have a set of labs, actually, in Munich and in the Bay Area, where if you want to deploy your application and you don't have robotics, we have it. Yeah, you can actually deploy your simulated application into a real physical cell as well and see it running in real time if you want to do that too. So if you want to play, or you have a real task you want solving, you should come and try us in October.
Yeah. So, I mean, in the abstract, those are great answers. Can you say something specific about like what are actually being done?
Sure. Maybe let's give an example. When we recently showed a work cell running in Automatica in Germany. It was basically taking a PHEV module and actually assembling it to a engine frame. But it was using basically, you could basically assemble screws, nuts, in a sophisticated way onto the frame, move that frame, and also disassemble it. But then we actually showed if you move any of those component parts, the whole system could reconfigure itself in real time. And why is that? It's because we're using things like vision and touch as well in order to adapt the system with a closed information loop, if you like. And I think that was pretty powerful, but we actually showed it running in a process flow simulation that somebody had designed, then running in reality on the hardware simultaneously. So you can actually see both things running at the same time. But that was actually quite a complex assembly set of tasks, which actually, to be honest, even if you ask anybody in robotics today, even doing something like a screwing task, if something moves, is actually quite complex to adapt to.
Yeah. Yeah, I love that. You mentioned that you have a bunch of labs all over the place, and earlier this year I was in the Google Robotics labs, and I saw a lot of really cool things in demo. Unfortunately, most of the things I saw demoed are no longer around. There was a bunch of that got shut down. Why do you feel you guys will be different within the Google umbrella?
We're already different in that we're actually already a separate entity. So I don't know if those of you know understand Alphabet. There's companies like Waymo, which is actually a smaller sister company to Google. We're in effect the latest version of that. We're actually already a separate company. And that's because actually Alphabet, we validated enough in the real world already with the real customers that we've actually become this separate entity. So that's for one thing. So we're actually protected that way. We have our investment. Also, it's because we actually have real customers actually trying our software. And we actually have a real product as well already out there. To be honest, in terms of those other companies, they're also still, some of that talent and learning is still part of the Google ecosystem and actually our ecosystem too. So there's great learning, I think, there.
Yeah, no, I get that. It feels like a lot of the people who were involved in that were also involved in layoffs and stuff, though, over the last couple of years. And like, the reason why I'm passionate about this is I want these two projects to exist. And I'm like, come on, Google, or come on, Alphabet, leave them alone. Do you feel safe in that? Do you feel like you're going to continue to receive the support you need to continue?
We do. I mean, we're very well supported and well resourced and well funded. I think, as you know, we actually did 2 acquisitions recently, including Open Robotics with Brian and Vicarious recently. And I think that's very much a commitment to the vision and mission we have, that actually Alphabet has supported us in that. Also, we very much are both entrepreneurial in that respect. We very much take a one-on-one bet where we put our time and energy. And so far, I've never done a business where that hasn't kept growing.
Right.
And Brian, for sure, the same.
Yeah, and I'll say that it was, when we were running Open Robotics independently for 10 plus years. And so why would we think about making a change and committing to join another company, in particular Intrinsic? And one of the things that really made the difference for me was that it was not just a robotics research project within a big tech company. Like Wendy was saying, it's a separate entity. So it's a group of people who have decided to take this jump to leave the mothership and go all in on robotics. So we're gonna, the way I think about it is we're gonna live or die in robotics. There's not a path where we just say, well, that was fun. Let's go back to doing something that Alphabet does. there's a level of commitment there, both from the people that are involved and also institutionally from Alphabet, that I think has given me the really strong confidence that we're gonna have a shot at it, right? It's up to us to actually make it work, but I think I think we've got a really honest shot.
I feel like across the industry, people who are relying on ROS, they were like, some people are like, yay, now it's very well resourced, and some people are like, oh God, what's going to happen next? It's funny that you brought that up. Like, what is the thing that is possible now that wasn't before?
So if you've used ROS, and I hope you have, in robots that you've built, perhaps one of the things that was never really obvious was that the core team that was really maintaining and developing that software, we were able to do that by bringing in basically like consulting customers who would support the development of it. And that, if you've ever run that kind of business, it can be actually quite challenging to ensure like ongoing stable support. And I think I'm really proud of the way that we were able to make it work. But what we saw was that we needed to have a step change in order to really take that development to the next level and be able to really provide what the whole robotics community needs in ROS. And that's really what motivated the decision to merge with Intrinsic, honestly, was that it was an opportunity for us to be able to have this, like, to turn up and really commit over the long term to supporting all of that open source software, and to do it not out of a sense of like altruism or charity, right? We're not just doing it because we think it's good for the world. We're doing it because we're also relying on those tools ourselves, and we're building our own really scalable business on top of it.
Yeah.
I think it was important for us that, Brian, we really cared about the open source community. I mean, for those of you who've been devs in the past, it's those communities that knew me drive step change in industry, usually. So we thought about it very carefully. Intrinsic had already been contributing to ROS itself anyway, as part of the community. And so when we were thinking about actually merging together, we thought both ways about how we're going to protect that community. So we actually continue to invest in it. In fact, actually, there's more resources now that are dedicated with Intrinsic specifically to the open source. I mean, to be quite honest, in the future, we may well open source more ourselves into the ROS community from Intrinsic as well. We think it's a symbiosis there. I also know to step change and disrupt the whole industry, you cannot do it on your own. And actually, the open source model works very well, but actually a whole ecosystem model works very well. And I felt that Brian and his team had a super strong DNA understanding of that. But what joins us together is we genuinely both actually wanted to democratize the access to robotics. I've always been about democratizing technology in all the businesses I've done. And Brian's put his whole career on betting on that. So we're in it together because we actually really want to make it happen, which is back to your question about why we believe. Mm-hmm. This is going to be the one that actually shifts the ecosystem on behalf of everybody else. The whole world still runs on GDP. I think, we can't eat the metaverse. I think there's an element of we actually do need to think about sustainability and production with declining birth rate, et cetera. How are we actually going to deal with that in the world in this next period?
Yeah, no, absolutely. You mentioned that you might consider open sourcing more of the software you're developing yourself. Can you say anything about like which parts or which direction you are thinking there?
Well, I think that it doesn't make sense to just like take a random piece of software and throw it out into the world. You actually take some consideration to think about what's the value that this is going to provide, and can I provide it in a way that people can really make use of it, and can I commit to supporting it, right? That kind of bad examples of open sourcing things are just to you take some code, toss it over the wall, and go on your merry way, right? So when we think about what makes sense to be open sourced, we really want to look for the things where we've produced something internally that we think it's really going to be a game changer for folks out in the world, and it's going to be reusable, right? It's not something that's specific to our software stack, but rather it's something that people can use in a wide variety of settings. And they're going to be, we don't want to say specifically which pieces we would put out there, but we're starting to do that analysis right now and think really carefully about which are the ones that we think would really be valuable to the robotics community generally, and also the ROS community in particular.
Yeah. So this panel is specifically kind of edging towards education in robotics, and we've talked about no code. I think I can wrap my head around that. In the context of this, what does low code mean, and what languages do you have to learn in order to program those parts of it?
I think we're saying at the no-code level, it's obviously sort of a graphical user workflow interface, which some of you will have seen in other types of software. At the code level, we're trying to, it's targeted more at a sort of Python level developer, so almost more like standard scripting language. So we want to make it very easy to use, library-based, an environment that actually Python developers would be used to. So that's the sort of level we're aiming at. But we're giving them access to the skills and functionality and libraries of a more sophisticated, for example, an AI machine learning expert would have, or even a strong roboticist would have. We're also trying to abstract away things like, traditionally with OT environments, you'd have to understand more around lower level controls, PLCs. We're also trying to abstract that away too, so you don't have to become an expert in that as well.
Yeah, and so if somebody is sitting in the audience now and they're like, hey, I want to get into robotics, like how much do I actually need to learn? Where do you begin?
So honestly, what I would say is I would point you to ROS as a great starting point. There are fantastic tutorials and curriculums that have been put together around the ROS ecosystem that can introduce you to simultaneously the concepts that you need to understand about robots, like how do you interpret sensor data? How do you develop a control system? What are the kind of the fundamental concepts that you need to learn? But then also specific tools that allow you to implement those concepts, and as well as kind of existing implementations that you can just exercise. And nearly all that stuff can be tried in simulation. So that is going to be a great place it's a great path in that lets you kind of get used to what it means to program a robot, actually program it, run it in simulation. And there's a lot of breadth in that community as well. It's worth mentioning that while we're talking a lot here about kind of industrial collaborative robots, robot arms that are doing work that you would be kind of familiar to you if you were looking at like a warehouse or factory. But there's much more that's going on in the robotics community. You just heard Mark and Gil up here talking about a much broader variety of robotics applications. And we see some of the same software like ROS used by groups like them, but we see it used by, NASA has the Astro Bee is a free-flying cube that's about this size. They've got 3 of them on the International Space Station. They've got fans on all sides, and they fly around in the microgravity inside the space station. That runs ROS. That runs the same software that you can use to program, a wheeled robot in your factory or a robot arm. And so I think the key thing to point out here is that if you start to learn those concepts, they're really transferable. You can go from kind of toy examples up to, in fact, quite sophisticated systems, and the same tools and concepts are still there.
Mm-hmm. And I feel like for the longest time, if you were a automation engineer or automation engineer in one kind of bubble, it was very hard to transfer that skill set to another because the languages are different, all the things are different. And are we now in a place that it's possible to abstract it far enough that the skill becomes truly transferable?
I think we're getting there, and that's, if I think about what we're doing at Intrinsic, we're really, in particular, starting with bridging that gap between what's been historically the realm of, strictly automation work and the broader, like basically bringing in modern robotics concepts that are in fact transferable. I think that, if you think about where robots have been used over the last 50 years, it's mostly been in these kind of really strict, rigid automation settings. And it's been a great place to get robotics started, but also they tended to develop their kind of own silo way of doing things. And in parallel, the broader robotics industry has actually advanced tremendously in terms of perception and control and planning. And so we're really bringing that sort of modern technology that's available, bringing it to bear on these kind of long-standing older problems.
Mm-hmm.
I think the abstraction as well of putting almost a layer of business logic or task flow on top of that. You can see the step change from there will also come with things like generative AI. So Gen AI right now, once you know that, if you can abstract out that business flow and like let's say task building logic, at some point, it'll just become a prompt-based interface. You won't even need a process flow or a graphical user interface or even, ultimately, Python coding, to be honest. And I think, it's one of the things our R&D team, unusually, even though we're just a new product, is already working on because of the step changes that are happening in the rest of, the tech sector right now. we're adapting to that. So I think this is actually very timely, that the abstraction we're actually doing is actually going to enable a very quick shift to what's going to be happening next around artificial intelligence.
Yeah. Well, I've seen some demos along the lines of where you can talk to a robot and say, hey, there's a can of Coke, please put it in the bin. And the robot goes scurrying around, so it has like a pathfinding, picks it up, knows where to put it, all that kind of, knows where to look. And I'm curious, like, how far are we away from being able to do that in a more industrial setting? Like, hey, fasten this thing to that thing.
Well, in a way, what I was referring to is starts to get to that, because one of the interfaces could be a natural language processing interface taking that business logic. So, for example, if somebody had what I described earlier of the sort of engine assembly task, there was already a workflow that we've created graphically that runs that whole process. So you can imagine it wouldn't take much to actually use voice command actually to create that flow or to edit that flow. But as Brian said, because of the computer vision and the force feedback sensors also there that can have a real-time response, an adaptation, you could literally say, look, can you move that piece over there, and actually can you then rerun the system? So, you know, I think for the roboticists, I think you would say this, Brian, as well, that seemed to be science fiction for a very long time.
Yeah.
But actually, it's now in the realms of the next, well, I'll make a statement, next 5 years rather than 20. Yeah.
Beautiful. I think that's a great place to end. Thank you all for coming. Thank you both for joining us.